So as I alluded when we were talking about feedstocks, and as a lot of other people kind of spoke to since we've been going through these presentations, we're going to move on to talking about compost quality and a really powerful, really simple tool called a bioassay that folks can use at your compost sites to kind of help check for some of these issues that can arise in your finished compost due to different factors. And I'm going to try to not be too sciencey about this either. So, so after you collect your feedstocks, you choose your recipe, you make your compost, you go through the whole thermal phase and all the turning. You're going to hit a point in your compost curing phase that's maturation. So it's maturing, it's curing, and different things are happening during this cycle. It's just as critical as the thermal phases are. It has a slightly different function in what's going on with your compost during that time, though. So during the maturation phase, as you can clearly see on my slide this time, we have an increase in fungal activity. So we talked a lot with feedstocks about woody materials that are really persistent in compost that don't break down super easily. Well, fungi in your compost is what's going to take care of those materials. They're going to break them down. They have the biological mechanisms to do that, which certain bacteria and protozoa and things do not. Fungi is not going to be super active in your hot piles because they do not like the heat and they do not like the disturbance of being turned. It's actually a benefit that some of these more static systems have is that you're not turning it, and the fungi really enjoy that. And you're also going to experience nitrification, which is just a really fancy way of saying nitrogen is going to be changing forms. There are bacteria that participate in this process. During the thermal phase, there's certain types of nitrogen that are being produced. And during mesophilic and cooler phases during the curing process, nitrogen is changing forms yet again due to different processes that are happening, mostly biologically driven. It's all about the microbes. And during your maturation phase is a really great opportunity to start looking at your compost and kind of assessing the quality of it. And there's lots of ways to assess quality. Of course, you are all aware, if you're a site operator or a regional coordinator, that everyone is getting a lab test of their compost sent in sometime during year 2, once you have finished compost that you feel good about, and they're going to assess that for you. However, that is not the only way to assess quality, and it's definitely not the cheapest way to do it. So when you get a compost test done, it's called, the type of testing we're getting done is a Seal of Testing Assurance program from the USCC, I believe, correct me if I'm wrong on that. And it's gonna look similar to this. There's several labs across the country that perform this kind of testing. And this is the information it's gonna send back to you. This is roughly what the report will look like. Sometimes there's different information depending on what you request, but this is the basic idea. And it'll show you plant nutrients, moisture content, organic matter, pH, salts, which is EC. And there's some maturity indicators, the emergence of certain types of weed seeds, germination rates of different plants, pathogens, and things like this. All very important information. So this is not an attempt to undermine any lab testing, but it's not necessarily the most accessible way to check the quality of your compost. Oh, well, it changed up there. So this was adapted from a document created by Lin Fang, who works with LA Compost. They put together a presentation during CCGS1, and they had these sheets that they sent out to everybody to help them interpret their soil analysis results. If anyone has ever worked with an agronomist and had them interpret soil test results for you, it's about $200 an hour to pay somebody professionally to do that. So this sheet was extremely helpful, and there are some other resources online you can look up that can help you interpret those results. So these aren't the exact parameters that were on that test, but in general, these are the things, the kinds of information you're going to get from those tests. And this also shows the range that's ideal for your mature compost, and what it could potentially tell you if you're out of range for that certain parameter. Any questions about STA testing?
Does that do anything for pesticides? Any pesticides?
No, it does not. It's actually quite difficult to test for those types of chemicals in compost with a wet lab analysis. So with a chemical analysis, it's very expensive equipment typically that gives you that kind of information. So no, not typically. That's where the bioassays come in. And it's actually a tool that professional labs will also use, and it's quite simple. Any more questions about STA testing? I know it's late in the day, and that is a really complicated sheet. Okay, and this will all be available to folks, yeah.
Is there anything important on that sheet that would, like, we would be looking for?
Everything.
Yeah. These are all very important factors in your finished compost product. You know, organic matter percent can help inform how you're going to use your compost. Is there food left over for microbes so that when you put it on your soil, that cycling can continue? Or is it just nutrients, or is it just microbes? So it tells you kind of what that whole package is made up of. And that can help you decide how to apply your compost or what the best use for it would be. Yeah. Any more? Oh, yeah.
Is there anything on this chart that wasn't on the previous test?
I think all of this is included on that other sheet. That other sheet had a few more parameters,
okay,
actually. And it's just what you request in your test results too. Usually there's add-ons. All right, so that's the complicated part. We made it through. All right, so I'm gonna show you some things that you can do that don't require a sheet like that. It's very simple, and we can actually touch some compost, which that's my favorite part. So on this slide, I have moisture and texture, but I'm gonna actually step back one more step, and something that you can do, you can smell your compost. You can go out, dig around in that pile, you can feel it. Is your compost still hot? That's one of the first indications that it is not done decomposing. You're not gonna have a healthy soil food web present. There's gonna be not the right forms of nutrients for plants that are gonna be available to them, and it's gonna cause a lot of problems in the long run. So temperature is one of the first indicators. You don't even need a thermometer for it. If you stick your hand in and it feels uncomfortable or it feels like body temperature, it's too hot and you have to let it go. And smell. There are certain smells that come with immature compost and also with anaerobic compost that are very special, and you will never forget them once you have smelled them the first time. I affectionately call my buckets of food waste the bog of eternal stench, if there are any Labyrinth fans out there. Because once you touch it, you cannot wash the smell off. So these are things you won't forget. And hopefully tomorrow we'll get to dig around in some piles and experience some of these smells, because healthy compost has an incredible smell that you will also never forget. And there are some buckets in the front here. Oh, no, not the right bucket. Of some really amazing compost, and I encourage you to pass this around and smell it. It's a good one. It's not the bog of eternal stench.
It's just a push bag.
This is a good one. So good finished compost should smell like a forest floor, or when you walk outside after rain and you get that really earthy scent. It shouldn't smell like urine, it shouldn't smell like ammonia, and it also shouldn't smell like the fresh feedstocks that you put into it. Lots of different types of wood, you can smell those different resins and volatiles that come on them, and you honestly shouldn't be smelling any of those individual smells, whether they're good or bad. So that's the first thing, like use our senses, right? We can get so much information. And something I want to keep in mind throughout this presentation is you don't necessarily have to know exactly what's wrong. The point of all this is to just identify that there's a problem, because then you can find someone to help you. But if you don't know you have a problem, you don't know that you need help. So we have a whole community of folks here with an incredible amount of knowledge shared amongst them. So there are people who can help. So now back to my slide. So moisture and texture are also two really important things in finished compost, because compost is going to help solve those problems in your soil when you apply it. So it has to be able to hold moisture, but it also has to have a texture that allows moisture to drain. So we have a really simple test. It's real fancy. Took years to learn this one. So you take a wad of your compost. We call it the squeeze test. I'm sure a lot of you are familiar with this. You can also do this when you first mix up your compost ingredients for your initial recipe. Although for me, I use wood chips, and it's hard to squeeze water out of wood chips. So you take a handful, you close your fist, and you squeeze. It's actually a little too wet. So what you really want is to get maybe 1 or 2 drops when you squeeze really hard, and that's about 50% moisture. And that's where you want your compost to be at throughout the whole process. So in the beginning, when you first build your piles, all the way through to when it's mature, you really want to maintain that moisture for the microorganisms. And the other part of this test is after you squeeze that handful super tight, you look at the texture of the material that you have left in your hand. Does it break apart easily when you squeeze it? Does it have these kind of clumps but still fall apart? You don't want it to smear like clay. You don't want it to be super muddy in your hand. This is actually pretty sticky. But you also don't want it to just immediately crumble as soon as you open your hand, because that's going to be way too dry. So moisture and texture, super important. Another thing I get when I touch compost is after I drop it out of my hand is still coated. So all that kind of gooey stuff that's stuck to my hand, that's all these organic compounds that are being created and aggregated by the microorganisms. It's all the things the microbes are exuding into your compost that add carbon back into the soil and hold everything together. They create structure and drainage. So you want that to still be on your hand. It's not really slimy, and the chunks of compost still come off, but it's so hard to wash off. On it. All right, so super simple tests that can help you. I'm not going to put my hand on your laptop, Courtney. Super simple tests, really powerful. So now we're going to go on to something that's a little bit more specialized, but I hope still feels very simple to use, and it's a bioassay. So there's actually a ton of different information that you can get from these kinds of tests, and there's an explanation of what these tests are. You use compost feedstocks. You can do these for soil. It doesn't really matter what material you're using as far as compost or soil, but there's a lot of information you can get from them depending on what you need out of it. And what you're doing is you're growing plants in it. And based on what your goals are, you choose different kinds of plants, and you look for different types of things happening to those plants as they sprout and grow. Oh. So these are some things that you can find out from a bioassay. A lot of these things you'll notice were listed on that soil test sheet. And also, something that I beat to death in the beginning with feedstocks is this is a really great way to test for herbicide contamination. Because even as you saw on that test sheet I showed you, there is not a box for testing for herbicides or pesticides in your compost. So you can also pH imbalance, EC, those two particular items, how they're going to present themselves to you is in some kind of nutrient deficiency to your plants usually. Those can be a little bit more complicated, but the damage is all quite similar. So if you notice that type of damage to your plants, it's a good indication that they're not getting nutrients. Nitrogen specifically has very clear indicators. It's pretty easy to tell when a plant has too much or not enough nitrogen. Too much is also a thing. And then seed viability. So this is germination rates of things you want to grow in your compost, and also to test for the viability of weed seeds if you haven't quite gotten your process down yet. This is a bioassay. It is an incredibly simple setup. You want at least 6 containers. This can be any size. You can use gallon pots that you have laying around at your nursery. You can use seed starting trays that you have in your greenhouse at home. You can use plastic milk jugs. Any kind of container that you can sprout a seed in, you can use for a bioassay. 6 is definitely the smallest number. That's just based on experimental design. Doesn't really matter why. 6. 6 is the smallest number. You can do more if you want to have more comparisons with your results. But 6 is a good number. And you're going to have 3, if you can read that on the slide from where you're at. The 3 in the back say clean, and the 3 in the front have question marks. So half of your containers are going to possess some kind of potting mix, some kind of material that's been quality tested, that's registered and labeled, that's gone through all of these processes already, because that's a baseline. The second half of your containers is going to have a mix of that exact same material and whatever you're trying to test, be that soil from your garden bed, be that compost that you're making, and a 50-50 mix is a perfectly acceptable starting point. You can tweak that a little bit if you want, once you start feeling confident, but that is the very basic setup for this experiment. And as a side note, you always have factors that you want to limit and control in any experiment. It's experimental design, certain variables. The more things you can keep the same, the more power you have in your results when something's different. So amount of soil that you're putting in each pot, keep it the same. The amount of water you give each pot, keep that the same. Temperature, try to keep that consistent. Access to light. Those 2 things you might have to supplement if it's cold in your house or if it's wintertime. And make sure all of the seeds that you're planting are from the same packet, because that's going to be the age, the handling. It's going to hopefully make them a little bit more the same. We know seeds are never all the same, but. So these are some of the different types of bioassays that you can set up. Well, not the picture to the right. So on the left, something you might want to test for is whether weed seeds that are left over in your compost are viable. So what you can do, as they did in this picture, is fill up a tray with a bunch of soil. This bioassay is actually even simpler than the one I showed before. And if you know what type of weed seeds you're looking for, you can look up information about what kind of watering and temperature they like, or you can just water it, add light, and keep it warm, and see what sprouts. It might take a little bit longer. This study, you can see the plants are just starting to come out a little under 2 weeks after they set it up. Some weed seeds take a little bit longer. So minimizing inputs of seeds in the beginning is probably your best bet. Actually, in that bucket of compost down there, we made a Johnson soup bioreactor out of Scotch broom, which is a huge invasive plant up where I live in the burn scars from the wildfires. And we did notice a couple weeks in and then a couple months into the processing of that there were seeds sprouting. But it's been 1.5 years now, and it's been almost a solid year since any more seeds have sprouted. So we're going to do some weed seed tests on that. Yeah?
Are the pictures peaks and valleys?
Those are, I'm pretty sure, all deficiency symptoms. It's going to look a little bit different if there's too much. Usually nitrogen is the one that you notice when there's too much. Yeah, so it was to try to keep it very simple. There's definitely loads of resources online. If you're testing your compost for EC, pH, or nutrients, you're going to set up a bioassay like this. And then you're going to document damage. So those were just some examples of types of damage you might see that could indicate EC or pH because those are nutrient deficiencies. Yeah.
On that, the weed seed test, you said you are mixing that 50-50 with soil and compost, or is that just straight compost?
That can just be the straight material.
I see.
Yeah, that's probably the simplest of all. It's just taking care of it as if you were putting it out in the field and then seeing what sprouts. You can mix it. It's up to you. And then another really important tool, or way this tool can be used, is seedling germination. So making sure that you're creating the conditions that seeds want to sprout in. It's another problem you can have. Seeds can sense the environment around them, and they will wait until the conditions are ideal to sprout. So if your compost is not creating those conditions, you can put plants in, and it's either going to take them a very long time to sprout, or they're not going to sprout at all. Or it'll be very patchy across the tray that you plant. So very simple, hopefully. Oh.
Sorry, on the
Oh,
germination
you're good.
rates, is there like a measurement? Are you looking at percentage of seeds that sprout, or just if it does or doesn't sprout? Is there a gradation there, or what do you?
Germination would definitely be a percentage that are going to sprout. So if you see really sparse sprouting, that's usually an indicator that something's wrong. Yeah, and then also, well, yeah, pretty much. You're looking at a percentage, or whether they just don't sprout. As with anything, you know, if it doesn't sprout, you might want to try again before you jump to any conclusions. Because if you don't know the state of the seed that you got, there's a chance it could be the seed. So always try things more than once before you draw any super severe conclusions. So the final form of this bioassay that I want to talk about that I am extremely passionate about is testing for herbicide damage. So I know in our feedstock conversation, I did talk a lot about how thermal composting will degrade almost all of the common fungicides, pesticides, and even a lot of herbicides. However, there are two particular herbicides that are extremely resilient even to microbial, UV, and thermal degradation. That's aminopyrrolid and clopyrrolid. There are certain class of herbicide, that's not important. The fact is, in soil conditions, some of these herbicides can last up to 5 years. They do not break down readily. Some of them can detach from the plants that they targeted and killed and be released back into the soil and continue killing plants that may not be target species. It's a problem. Washington, Pennsylvania, and California have all been identified as having issues with these herbicides contaminating commercial composting systems. So it's an issue. It's an important thing to test for. These herbicides specifically are for controlling broadleaf weeds, but what that also translates to is they will kill lots of garden vegetables because they are also broadleaf annual plants. And so those are also the kinds of plants that we select to use in these bioassays because they are very sensitive to those types of chemicals, and you're going to see the damage right away. And it's quite unique, and it's part of the reason I wanted to show you some of the nutrient deficiencies so we can kind of compare that to what herbicide damage looks like. I don't know how this video is going to look. If it's super seedy, we'll just talk about it instead. All right, I'm not going to play the whole video. But as you can see, it can be very deceiving when you have these feedstocks. Like, you might see things growing in those piles just because they're a type of plant that's not affected by these. And then you get it into your veggie garden and notice that there's a problem. These things carry through in composting. There are some studies that have been done that, how do I go back now? There are some studies that have been done that do show that they do, these materials do still break down faster in thermal composting. So it's still good to put them through that process if that's what you're stuck with. But yeah, we definitely don't want to be passing these things out in our community and setting people up to fail. So this is the results. Montana State University has a really great protocol. This particular link right here, it'll be a link once I share these slides with you, has a full-on step-by-step protocol for performing an herbicide bioassay. It's super simple to use. And they even have these photos like the one down below, which can help you figure out the concentration of that material in your compost. So it's not just knowing that there is a problem, it's actually understanding the degree of the problem, all just with visual aids. I'm a big fan of bioassays. Okay, so last but certainly not least, I'm going to chat just for a second about microscopy. It is something I've done for a long time. I enjoy it very much, and it's a lot of fun to show people their soil under the microscope. And you can get so much information from what the microbial activity is that's going on in your piles. So the soil food web, this is the reason that we can use microscopy. Yeah! This is the reason we can use microscopy and tell so much about our soil, because soil has an entire microscopic ecology happening. And what we're doing primarily, in my opinion, with composting is trying to create this web of organisms to put back into the soil, because they control nutrient cycling, they help control hydrology in our soil, they support plants. I know I'm over my time. And they're really the driving force behind all of the things that we're trying to accomplish with composting. And I'm going to end on a quick note of one more video, because I just want to make this difficult, of something I filmed under the microscope that I thought would be exciting to share. Save me, Courtney. Apples. It's okay. I'm not sure it likes this one. Oh no.
There's that big X on it.
Oh, it does?
Yeah.
Oh. Okay, well, we're not going to watch the video.
We'll hold you in suspense until Sunday, when you can come back and see microorganisms moving under a microscope.
And you can pick my brain and ask me all of the questions about that then, because it's a long conversation. Any final questions? Yes?
So in our composting system, we're looking at probably using, we're in a ranching community, so there's lots of cattle. And so you test to see if those herbicides are in the food before you run it through a composting system, so you don't end up like bringing all that stuff in and then just wrecking the whole system?
There are some tests that people perform. Essentially, you're taking some of your feedstock materials and kind of like massaging them in water, hoping to get some of that off of the bulk material, and then using that to water seedlings, trying to not have a ton of runoff, and hopefully you're capturing those in those pots, and it's going to immediately affect the seedling. You also don't have to perform these tests from seed. Obviously for germination that's important, but if you're just testing for herbicides, you can take sprouted plants and just plug them into those pots, and you're going to see results a lot faster that way.
So basically we need to see what are the different herbicides there in the market and what are they for. So basically go those seedlings and start experiment with your product.
Yeah, it's a really great way to test our compost without having to get a lab involved.
Yeah.
Yeah. Oh, I think Bob had his hand up first.
Is there any way that this kind of damage from these pesticides could maybe manifest itself in other ways, like showing up as root knots and things like that? Have you ever seen that?
On a root level, I'm not sure, other than stunted growth. That's the most common thing that I've seen. Mostly it's what you see in the tops of the leaves, and it's very unique in that there's not a lot of burning and yellowing necessarily right away. It's this curling that occurs. So a perfectly green plant, and suddenly it's doing this really aggressive curling in the leaves. Peas, you see it really significantly in. But you noticed all of the tomato plants in the guy's video, they had that damage without any yellowing, without any burning going on yet. So that's usually the most indicative damage that you're gonna see that will suggest herbicides. Yes?
I was just curious, the commercial products that have the amino pyramid, are there names that we could ask people?
There are. The most common one is Grazon. Folks spray it in fields, but there are a lot of retail names for these chemicals too. It's not going to be called aminopyrrolid or clopyrrolid, and there are lists online if you look up that active ingredient that will tell you. Yes?
Is there any of that, I know that Carl on the tomato plant, is there any way, any other way for the plants to get infected or for that to happen without putting indoors?
Yeah, so usually the most common ways that you get contamination would be from one of your feedstocks if you're using compost, or if you're mulching with something like straw. Rice hulls are another big one that can carry contamination. So feedstocks and compost, mulch materials, compost that was put in a soil mix that you're using in your garden beds, and also drift. If you are not a licensed organic farm, the people who are operating around you can spray whatever they want, because there's not a lot of accountability for that. So yeah, drift is another potential factor, like these materials literally blowing onto your property from improper spraying practices. It's a scary world out there.
So, is there a way, so like that looked a lot to me like it could have been some sort of a wilt or like a fungal infection or something like that. Is there a way to tell, or you just have to do side by side, like it's not a fungal infection or it's not a genetic infection or something like that versus the pesticide?
Yeah, I mean, just like with everything else, there's a lot of observational factors to take into account. Like, do you have a history of disease in your area, like in your plants in that area? Are there unhealthy conditions that might suggest disease? Yeah, and also if you're composting properly, and we're talking specifically about compost, if you know you've been getting up to temperature, the likelihood of disease is much lower. Not impossible, but much lower. So it would be worth.
Is there a way to go back and say, okay, I'm 99% sure this is pesticides. Now what's the next? What would be the next step to like 100% no, okay, it's definitely a pesticide?
I would go back and talk to the people you got your feedstocks from. Yeah, go ahead.
Also, if you, sorry, go ahead. Also, I was wondering if I buy a seed from Johnny Seed Log, they say it's pure, it's tested, germination rate, everything they did, so that it's pathogen free. And if that's symptoms coming into my seedling after I put that, my compost tea or whatever I start to put it, then that gives me some confidence that, hey, this is a tested seed coming from a professional background, so that I can doubt more on compost side. That's one thing.
Yeah, and there's always a degree of uncertainty, right? We can't 100% be positive. As far as different types of damage go, I didn't represent a lot in these slides because I wanted to keep it simple, but there are whole pools of information online for every specific plant, specific diseases. and what that damage looks like, and it's going to have very detailed information for you so you can do a better analysis too. This was a very, very quick overview. All right, Garrett, and then I gotta go because it's Daniel's turn.
Yeah, so if we're doing the seed germination test at the same time as a bioassay, if we're getting the weed seed germination test, then if we're seeing like more than 50% of the compost, or there's a fair amount of weed seeds germinating in the compost, then there's also the question in our bioassay, right, that there might still be things that are not these two particular things. Is that correct?
Yeah, if you have results like that in any of your tests, it might be worth going back and considering other things that may not have broken down. Absolutely. If the conditions are inhospitable for any reason, it's a good opportunity to go back and look through your recipe and maybe do some of these other tests and see what happens.
And so, sorry, I know we're trying to wrap up, but that germination of weed seeds is also a good indicator that really kind of one-to-one with pathogens. Is that correct? Or like, could we sort of say that, or is that not quite?
I don't think that would be a poor assumption.
Okay.
I would be concerned of potential pathogens, but again, it's about monitoring your feedstocks, knowing where your materials are coming from, and developing these relationships, because just like Michael was talking about, developing relationships to maintain these community composting programs, we're also creating relationships with the people that we get this waste from.
Yeah.
So I think that's really important, and that helps maintain accountability. All right.